All right, guys, this is lesson 4. It's the composition of functions. So we worked on compositions earlier in the quarter. Worked on compositions earlier in the quarter, right? So for compositions, the things you have to remember is that graphically you can switch the x and y and create the inverse of a function. That's pretty much the point or the focus of what we should be learning today. So right now they give you an equation and they give you an x value. You just have to find the y value for each x value. So my first y equals, when x equals -3, it's squared. So -3 times -3 is 9. X equals -2, it's squared, so this equals 4. X equals -1, it's squared, so this equals 1. X equals 0 squared, that's 0. X equals 1 squared, that's 1. X equals 2 squared, that's 4. What we're going to come over and do is graph this quadratic. What we're going to find is that the inverse is a radical. It is a radical. So I'm going to graph -3, and I go up 9, go left 2, up 4, left 1, up 1, and then 0, 0, and I graph the point 1, 1, then right 2, up 4, and I could even graph right 3, up 9, and what I form is that parabola. Now my inverse, the inverse of this parabola, I can find it by switching the x and y's. So find inverse graphically, this is graphically, by switching x and y. So, for my first point here, I'm switching the x and y. Here's 9, -3. So I'm just going to go ahead and graph that. So right 9, down -3. Then 4, -2. I'm just going to write these points. 1, -1, 0, 0, 1, 1, 4, and 2. So graphing the points, go right 4, down 2, right 1, down 1, then 0, 0, up 1, right 1, up 1, right 4, up 2, right 9, up 3. And here's my inverse. Here is my inverse. Okay? So the inverse is the square root of x. It's actually plus or minus the square root of x. Okay? The cube root function, the inverse is the cube root of x. The inverse is the cube root of x. But we're going to find these points a little bit easier by cubing the x value. So -3 cubed is -27. -2 cubed is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. Then I come over here, I graph the points. So left 2, down 8. Left 1, down 1. And then 0, 0. Right 1, up 1. Right 2, up 8. And then I create my graph. So this is y equals x cubed. y equals x cubed. So that's this graph right here. Then we find the inverse by switching the values. So negative 27, negative 3, negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, and 8, 2. Graphing these points, I can't do the first one, but I can do negative 8 down 2. I can do negative 1 down 1. I can do 0, 0, 1, 1, right 8, up 2. And then I just create my graph, my curve, really. Make sure you do that correctly. All right. Then down below, number 3, the graph of the function g is shown. So I'm going to pick some good points here. I have 0, 0, that's 4, 0. And so the inverse would be 0, 4, right? So what we're looking for here, number 3, it says the graph of the function g is shown on the grid. This is g. Which graph best represents the inverse of g? So if I switch the coordinates, I get 0, 4. So the one that shows me starts at 0, 4, it's not A. This is right here is negative 4, 0, not A. Is it C? Yes. 0, 4. The vertex here is 0, 4. But B, that's incorrect. And D is incorrect. And you should always check one other point. So I'm going to check this point 0, 2. If I switch the x and y, is that on the other graph? And it is. So always check 2 points to see if an object is an inverse. So always check by switching the x's and the y's. All right? Now, for the compositions of functions. When we compose a function, it's like substituting a function inside of another. So we're substituting a function inside of another function. Okay? And what occurs here is we get something else. So we're going to compose a function. We're not going to worry about what it says above. All right? So we're going to compose h of m of negative 2. So first, we're going to focus on this portion of the function. Now I know that means we're going to focus on this function right here. And we're going to find m of negative 2. So m of negative 2, this means that x equals negative 2. So we're going to substitute it into the function. We get negative 2 squared plus 3. And make sure you're using the parentheses there. So I'm going to put that in my calculator, right? Parentheses, negative 2. I'm going to square it, plus 3. Enter. 7. So that equals 7. So m of negative 2 equals 7. So I'm going to replace all of this with 7 and have h of 7 equals my function for h of x is 5x minus 4. So here x equals 7. So 5 times 7 minus 4. This equals, simplifying, 35 minus 4, which equals 31. And this is my final answer. I'm circling it, and you should too. Now, h of m of x. How do I find it? Well, I'm replacing m of x. There's no x value to replace here. And I'm inserting it inside of 5x minus 4. So here is, this equals 5x minus 4. When the parentheses, when this is inside, when m of x is inside, we're replacing this x with what m of x equals. That's x squared plus 3. We're replacing the x. And that's going to give me equals 5 parentheses x squared plus 3 minus 4. And then we distribute this 5. We have 5x squared plus 5 times 3 is 15 minus 4. This equals 5x squared plus 11. So I might do this a couple different ways, but typically I'm going to work it this way. Okay? So next they're asking you to compose g of f of x. So what we're going to do, we have g of x, right? We have g of x, and we're going to write what g of x equals. So they're asking you to insert this equation into g of x. So the equation they're asking you to insert is this one. So negative 3x squared minus x is going to go into the x value. Okay? So I have negative 2 parentheses minus 4. Inside, I'm writing negative 3x squared minus x. Okay? I'm distributing negative 2 to this term. So this equals negative 2 times negative 3 is positive 6x squared. And then negative 2 times negative x is positive 2x. And then minus 4 comes down. And this is my final answer. This is my final answer. Okay? Now, you're going to have to try some on your own. Now, if the input is a number, your answer will be a number. If the input is an x, your answer will be an algebraic expression. So it's very important that you know how to do this portion, because if you don't, you're going to suffer for it later. So I'm going to go through this with you for looks like 2 more problems. So you need to, it's very pressing that you pay attention to how to do this work. So it says, are the following 2 functions inverses of each other? So what they don't tell you is that inverses, for inverses, this is from Unit 1, for inverses, in order to be inverses, f of g of x has to equal g of f of x. So they both have to equal x. This has to equal x, and this has to equal x. So we're going to try to practice how to do this work. So it says, are the following two functions inverses of each other? So I have g of h of x. The way I find out is check to see if it equals x. So I'm going to check this one first, and then I'm going to check the opposite, or the opposing, h of g of x. I'm going to find those two things. All right? So I'm going to erase this for right now and conserve the space that I have. Now I know that g of x equals x plus 3. G of x equals x plus 3. All right? So what we're doing is we're replacing that x with x squared minus 3. So this equals the radical, and then inside we're going to have x squared minus 3, and don't forget plus 3. So now we can simplify, and when we simplify, we see that this portion here cancels each other out. That goes away. I'm left with x squared. The square root of x equals x. So far it's checking out. These two equations might be inverses. They might be inverses. So I check the next equation. I have h of g of x. Okay, so we're going to start off with the h equation, which is x squared minus 3, right? This equals, this time we're inserting g of x into that x squared. So the square root of x plus 3, right? And we use parentheses because that's a big quantity, and it's squared minus the rest of the equation, the rest of h. We're going to simplify. Remember, radicals get canceled if they're squared. This becomes x plus 3 minus 3. This goes away. I'm left with x. And the goal here was to make sure that these two compositions both equal x. And if they do, yes, h of x and g of x are inverses, because the compositions equal x. The compositions equals x. So this is a composition and this is a composition. Both of these end up as x. So this is what you have to do. So we're going to check the next two functions. We have f of x and g of x. So we're going to check, does f of g of x equal x? So first we start off with what f of x is. It's 3 plus 2x. Then we're going to insert g of x into where the x is. We're going to replace that x with what g of x is. So that's x squared minus 3 halves. So I keep going, equals the square root of 3 plus 2 times x squared is 2x squared. And distributing to the second term, 2 times negative 3 halves is minus 3. Okay? Now equals the square root of 3 minus 3 cancels. I'm left with 2x squared. This equals, if I take the square root of 2, it's just square root of 2. If I take the square root of x squared, it's x. This does not equal x. This first composition does not equal x. So I don't have to do the second composition. So it's very important that you know how to do this to save yourself some time and trouble. Since, so we're going to write since, and let's look at the name of this composition. Since f, this is our answer here, is since f of g of x equals x square root of 2 and not x, this is not a composition. This is not a composition, period. Okay? Now what about number 32 and 30 and, oh sorry, 32. What about the next one and the next one? Same type of thing. They're asking us to find g of h of 1, but they're not asking us to find inverses here. They're just asking us to compose these functions. So what we're going to do, things I know. I know what g of x is, and that's what I start off with. I start off with x squared plus 4 plus 2x, right? And then it's asking me to insert negative 3/2 x into these x values, right? All right. And then it's asking me to evaluate it where x equals 1. So I have, replacing this x squared, I'm going to write h inside. That's negative 3x plus 2, and it's squared, plus 4 plus 2 parentheses. We look at h and we plug it in. It's negative 3x plus 2, right? And we're not done because x equals 1. So lastly, we're going to plug in what x equals as a number. So first, we plugged in h into the x values, and then we plug this 1 into that. Okay, that's the goal. And what we do after that is use our graphing calculator to solve the problem. So we have parentheses, negative 3 parentheses plus 2, and it's squared, plus 4 plus 2 parentheses, negative 3 times something plus 2. All right. And we put a 1 inside each time. Now what you can do to make this easier for yourself is to go to your graphing calculator and put this in. Hold on a second. And the only time you can do this is when there's a number inside, like that 1. All right? So I'm going to write it down exactly as I have it. So parentheses, negative 3, parentheses, 1, close parentheses, plus 2, parentheses, up arrow, squared. Now, okay, keep going, plus 4, plus 2, parentheses, negative 3, parentheses 1, close parentheses, plus 2, close the parentheses, enter. And I get 3. Another way of doing that is pressing 1 stow X. Okay? And then, so we're going to store 1 into X. So 1 store X, enter. And then you write alpha trace. You go to alpha trace. We're going to store these functions in. This is going to be y1. This is going to be y2. So we're going to say that y1 equals x squared plus 4 plus 2x. y2 equals negative 3x plus 2. Right? And then what we're going to finally type in is y1. We're going to type it in sort of similar to this. y1 parentheses y2 parentheses 1 close parentheses. And the reason we can't use f and g and h is because we just don't have those functions. We only have y1, y2 up to y0. So y1, we're going to store these equations in here. So x squared plus 4 plus 2x store alpha trace, enter, enter. Oh, did I do it wrong? Yeah. Here we go. Actually, we write it into we go to y equals. You go to y equals. So x squared plus 4 plus 2x. You can only use this method when there's a number in the middle. Negative 3x plus 2, second mode. And we have we press alpha trace, enter, parentheses, alpha trace y2, parentheses 1, close parentheses, and enter. And we get 3. That's graphically. So you have the graphic method. Now for the next one, we can't use that method. All we have is g of x, and all we have is f of x. So we're going to write f of x first, x squared minus 2x minus 1. So for x squared, it's going to become x plus 5 squared. For negative 2x, negative 2, or negative 2 times x plus 5. And then we just get minus 1. Then we have to simplify. This becomes x plus 5, it's squared, times x plus 5. All right? And then we get minus 2x. Negative 2 times 5 is minus 10, minus 1. And we simplify some more. I get x squared plus 5x. And then 5 distributes to x, so positive 5x plus 5 times 5, or positive 25, minus 2x's. And then right here, this is just negative 11. Okay? Combining more like terms. So here's my like terms. Right? And I end up with equals x squared plus 8x plus 25 minus 11 is 14. Let me make sure that's correct. Yeah, 14. This is my final answer. If you notice in the last one, we got a number. In this one, we have an expression. And it's only because there's a 1 inside where this x is. Okay? Moving on to compositions with tables. So a few more ways to look at compositions of functions. So we always start on the inside when we're using the tables, and then we move out to whichever function we're working with. So for f of 2, x equals 2, I want to know what f of this 2 is, and I look over and it equals 3. Okay? For g of 1, I go to where x equals 1, so it equals 1 right here, and here is g of 1, it equals 3. For f of 4, it equals 2. Now I'm going to find f of 4 first. So when x equals 4, what is f? And then x equals 4. I want to write this out so you know what I'm talking about. So first we're going to find f of 4. So f of 4. This is when x equals 4, right? When x equals 4, f of 4 equals 2. It equals 2. Now at this time we go back up to the x column. You go back to the x column right here and find g of 2. And final answer here is 2. These are things we did early on. You should be familiar or recognize this concept by now. Here we start off with x equals 4, and then we go back to the x column for whatever that g is. So x equals 4, g is 0. So I want to find what f is when x equals 0. And I get 1. What I like to do is follow a path. So x equals 4. So I go to the g column, it's 0, go back up, and we're looking at when x equals 0, and we want to know what f is, and it's 1. So we'll try that again. We'll try it again. You should always end up with some kind of z. Okay, we start off with x equals 3, then we go to f, so x equals 3, so it's 0, and I go back up to 0 and find g, and it equals 4. Yeah, we'll go back and fix that. So for f of x equals 3, when y equals 3, what is x? So when y equals 3, when f of x equals 3, so I'm going to go to the f of x column. I'm going to go to the f of x column and find this number. When f of x equals 3, what x value is attached? It's 2. It's 2. When g of x equals 1, what is the x? It's 3. It's 3. Okay? Now, use the graphs below to answer the questions 8 through 0. Right? So, graphically, for A, we want to find s of -3, s of -3. So let's make some clarifications here. This is r of x. This is s of x. All right? So when x equals -3, what is the y value? So I'm going to go to the s graph, the s of x graph. Find when x equals -3. Here's when x equals -3. Go to the graph and figure out what this y value is. So here, x equals -3. The y value here is y equals -4. So I would write -4. 4. We're going to try it again with letter B. For r sub 0, that means the x equals 0 here. So we go to the r graph, we go to where r equals 0, this y value is 0. So I hope that made it easier for you to do these problems that we're about to do. So we're just finding x and y values. So for r sub 2, x equals 2. So I'm going to go to 2 and go up to this graph. This y value here, this y value is equal to 2. Oh, sorry, wrong graph, wrong graph. We got to be careful. We're looking at the r of 2 graph. So right arrow over to 2, and I go down to the graph that equals -2. For s sub 1, when x equals 1, I go right 1 up to the object, and that is 1, 2, 3, 4. My y value there is 4. For r of x equals 3, this is when y equals 3. I'm looking for x when y equals 3. So I go up to where y equals 3, 1, 2, 3, go over to the graph. This x value equals -3. So I want to know for s of x equals -4, or when y equals -4, what is x? So I go to the s graph, I go to where y equals -4, 1, 2, 3, 4. X equals two different values. X equals -3, and if I go over to the other x value, x equals 5. So x equals -3, 5, and I use curly brackets for the two values. And pretty simple and straightforward with that. For the last one, we're looking at g of h of 2. So here, x equals 2. X equals 2. So what we're going to do is find h of 2 first. So h of 2, the y value at 2. So here's 2. And the y value here is 0. It equals 0. So I'm going to plug that in for g of 0 graphically to find the final answer. And I go to where g equals 0, and it equals 0 here at +2. So the answer is +2. This is the actual answer. This equals g of h of 2. So my goal here, find what's inside first. Okay, so that means I'm going to find g of 2 first, right? And we know that x equals 2, because that's the number inside. So g of 2, so let me go find 2 and go up to the green line. That's my g. So write 2 up to the green line. That value there is 4. That equals 4. So now I can find h of 4. I go right 4, go up to h, and this is a 5. This equals 5. This value is 5. For x equals 1, I'm looking for g of 1. So I'll go right 1 up to g. Okay, and then get h of 3. So I go right 3 up to, or at h. And h of 3 is 0. Now, we already did a little bit for proving inverse functions. So when we're proving inverse functions, basically in general, if we have f and g, the composition sometimes might look like this, but it's the same thing as saying f of g of x, right? Well, in order to prove that these functions are inverses, f of g of x has to equal x, and g of f of x must equal x. So if f and g are functions, and this part is true, then f and g are inverses. Note that y equals x is the identity function, and the line over which a function and its inverse are reflected. So we're going to check, show that the following two functions are inverses of each other using a composition. So first over here, I'm going to check f of g of x. And then over here, I'm going to check g of f of x. So 7 parentheses, we're going to insert g in there, minus 2. So 7 parentheses are 1 over 7x plus 2 over 7. All right? So when I do this, this becomes 7 times 1/7, or just 1, plus 7 times 2/7. And I get these canceling. I get 1x plus, these cancel, those 7's cancels, 2. 1x plus 2. It does not look like this equals x, but I'll keep going. And I'll make a note. F of g of x does not equal x. I already know these aren't inverses, but we're just gonna check. So g of f of x. So that's like saying 1 over 7 times 7x minus 2 plus 2 over 7, right? These 7's cancels. I'm left with x minus 2 over 7 plus 2 over 7. I get x, this cancels. I get x here. So here, g of f of x equals x. But recall what we said earlier. Both have to equal x. Both have to equal x. These functions, so our answer is these functions are not inverses because f of g of x does not equal x. That's our answer. And we did our proof. Okay? So moving on. I think you have to do your homework at this point. You should be good to go. This is homework, supposed to be homework number 4, not 5. After this, you have a quiz next week, and then you'll have your review for Unit 6, and then you'll take your test for this unit. Hope you have a good day. That was the composition of